Welcome back. Now that I have given you all the information you need in terms of the solvent, the nature of the base, and the effect of the substrate, whether it's primary, secondary, tertiary, or methyl, it's time to put it all into action and summarize all four mechanisms really quick. Okay, with a bunch of examples, of course. All right, we have a first example here. Now, right away, first thing you would do want to focus is the nature of the base and the solvent. Now, this is a polar aprotic, right? And I believe I remember saying polar aprotic solvents almost always favor an SN1, okay? But don't get carried away with that, all right? Sorry, SN2. So don't get carried away with that. Always try to make sense of it. And then you do look at the base is your first aspect you do look at. But in this case, you know, it really didn't matter. But normally you should look at the base first. And this is a strong base, okay? And this is a polar aprotic solvent. And this is a primary alkyl halide, right? Now remember, whenever you have a bend, that corresponds to a CH2, right? If you have forgotten that from Chem 330, it's the same as writing this, right? All right, now this is a strong base, so your Na is plus and your OCH3 is your negative, right? So that reacts with, now what it does is, this is a strong base. It's not a bulky strong base, it's just a small strong base, and it's a polar aprotic solvent, and we have a primary alkyl halide, right? All this is in favor of only one thing, and that is nothing but an SN2, right? I'm going to write this primary over here, okay? And then I'm going to switch colors here just momentarily, okay? And then, so our nucleophile attacks from the opposite side of where the leaving group is. So, you know, what I could also do is rewrite this whole thing, okay? Now, for a test perspective, since it's multiple choice, you would just need to know what the product is, okay? And keep in mind, SN2 leads to inversion of configuration, right? So if this BR, okay, had been, you know, I'm just trying to put it in a format where, all right, let's just leave it here, okay? Let's leave the BR here and the two hydrogens here, okay? So your nucleophile attacks from the opposite side. So OCH3 minus, I'm gonna switch colors again, maybe a red. So it attacks from the side opposite to the where the leaving group is. Because it's an SN2, it's a conceded mechanism, so all of this happens at the same time. So okay. So this is the product of this reaction, and the reason we know, and the rate law would obviously be, you know, this whole reactant times your nucleophile, right? This is not a nucleophile, this is a solvent. It's a polar aprotic solvent, and the whole thing is SN2, right? Good. Now let's come back here. This is a strong base, so we know it's either SN2 or E2, and we have a heat, which further confirms our belief that it has to be a E2, okay? And then we look at our alkyl halide. This is a secondary alkyl halide. So if I redraw this, okay, just don't blindly look at the molecule and determine if it's tertiary or secondary. Actually do work it out, you know? So you have your Cl. So this carbon contains a Cl and two bonds. So the fourth must be a hydrogen, so it's a secondary, right? So when you have a secondary alkyl halide and you have a strong base and the heat, there's a high chance you could also have a minor SN2 product, but the major product has to be an E2, Okay, now because this side is a little bit more sterically hindered, you know what I'm saying? Because for the sodium oxide to come from this side, because of this bulky molecule, it rather prefers to attack from this side. This is a methyl. I'm going to switch colors here again. Okay, so it contains 3 hydrogens. I'm only going to show one of them. Okay, so what happens here is it comes and attacks. So this is a strong base, so we have a Na plus and a OCH3 minus, right? So the OCH3 minus attacks this hydrogen, and in the process the bond comes over here, and in the process the Cl comes out. Now it could have attacked from this side, but it can't. Why? Because of this bulky benzene group here. It could, but it will be a very, very minor product if at all it happens. Okay, what I'm saying is for it to attack from this side is too bulky of a group, whereas this side is not as bulky. So we are going to have, even though that's not following Zaitsev rule, but Zaitsev rule does not have to be followed. It's not like some kind of a firm law that we follow. It's whatever works. Okay, so this hydrogen has come off from the nucleophile. This bond has come over here, and in the process the Cl2 has come. Now you see all of this is happening at the same time. So this is an E2. Okay, now we will have an SN2 product in this case because it's a secondary alkyl halide, but it's going to be a very, very minor product because of the heat. It pretty much dominates it to be an E2. Okay, now if it had been a tertiary alkyl halide and a strong bulky base, it's almost guaranteed an E2. Okay, we will look at that in one of the future examples. All right, now let's continue it. This is again a polar aprotic solvent. Okay, and this is a strong base. Okay, and K is a metal, so K gets the plus and the Cn gets the minus. And this is of course it's got a hydrogen here. Let me actually change the color of that hydrogen. Okay, this is a secondary alkyl halide, right? And a strong base, which means there is a higher chance we will have both the SN2 product and an E2 product. Because there's no heat, we have an equal chance of this both being there. So let's look at the SN2 product. If it is an SN2 product, then all we have to do is get rid of the Br, you know, and throw in the Cn there. Okay, because what happens here is your Cn minus, right? Cn minus attacks this carbon and the Br comes off. So this is an SN2. Now what if it had been a E2? Okay, that means this side, this molecule is big, right? So it would rather favor this hydrogen over, well, this is where your leaving group is. So this is your beta hydrogen, this is your beta hydrogen. But for it to attack this side, because of this bulky group being there, it would rather prefer this. So let me redraw this whole thing again and explain what I'm talking about. Okay, let me actually draw it in a different color so it makes more sense. Okay, so you have your group, right? So this is your Br, okay? If it has to go through an E2, that means this is your beta hydrogens, right? Right? So it can have 2 products. Let's draw both of them, okay? Let's not make any judgment call right now. Let's just make both the carbon. So you have a hydrogen here. You have 2, in fact, and you have 2 here as well. We're going to only focus on one of them at a time because you only can remove 1 hydrogen, not 2. So your Cn minus comes and grabs this hydrogen, right, to E2. So this bond comes over here and the Br comes over here. If that's the case, you're going to have, this is where your double bond is, right? Now say it comes and grabs this, okay, right? So that means it comes, grabs this hydrogen, this bond comes over here, and the Br comes out like in the previous case. So your double bond is here. Now which one is the better of the two? Which one is more centered? Is this or that? Well, I'd say this is more centered. So this is the major product, and this is the minor product among these two eliminated products. But keep in mind, you could have also had SN2. Because it's a secondary alkyl halide and it's a strong base and a polar aprotic solvent, you could have both SN2 or E2. Okay, now in this case, this is a weak base. So sorry, this is a strong base, and you have a secondary alkyl halide, but we have heat in contrast to this. Heat typically favors an elimination reaction, but because it's a strong base, we can only have E2 and not S2, despite the fact this is a secondary alkyl halide, which can favor both SN2 or E2, but because in this, compared to this case, this is heat, so it favors your E2. So that means it's an elimination reaction. So that means either of these hydrogens can, this is your alpha, means this is your beta hydrogen. So I'm going to redraw this molecule here. And then use different color for the actual hydrogen that's coming off. So let's get a different color here, maybe a black. Okay. So keep in mind, this is your alpha hydrogen, which cannot come off. It's the beta that comes off. So both of these look identical. So either this or that would be the only product possible. Only one of them is possible. They're both the same. All right. So your O minus CH3, let me change color again. So that comes and grabs this beta hydrogen. The bond gets shifted here, and in the process, the leaving group comes off, leading to the formation of okay. So this is primarily an E2 because it's a strong base and it's a secondary alkyl halide and heat. Okay. Let me stop here and then come back and with another video on, I believe I have 2 more examples for you, and then the summary flow chart. All right, so stay tuned.